This is Team Cloud Nerds presenting IoT as a Service. Mr. Donut, the app developer, recently came to us with a problem. Here's how we helped him solve it. IoT as a service is any device, any sensor, one platform. There are currently 14 billion IoT devices. That's more than there are people on the planet. That number is set to nearly double by the year 2025, and it looks like we're drowning in data. But like Mr. Donut, sometimes we just can't seem to find the right data for our application. IoT as a service seeks to bridge this gap by offering a single consolidated platform that connects different sensor data formats and stakeholders in the value chain. Data does not have to exist in isolation anymore.
Okay, so let's go and see the high-level architecture and design of our project. We are showing here two devices connecting to the cloud and how our platforms helps in integration of both of them. The first device here is Raspberry Pi, and the other one is XDot, which is used for high range applications. Each device has its own unique device ID. Our platform helps in visualization of sensor data in the cloud based on the values being generated at the device end and passed on to the cloud through the gateways. There are three services backend running in the AWS, which helps in the device registration, the other services for the data management, and the third service for the portal, which shows the customer end interface. Now let us go and see the live connection of devices and see the demonstration of customer and provider interaction with our platform.
Let us look into the hardware setup for our project. So here we basically have two devices. One is our XDot and the other is the Raspberry Pi. So let's look into the configuration for the XDot. So as you can see, we have connected the thermistor for the XDot, which is continuously sending the data to the conduit, from the conduit to the router, and from the router to the AWS. So this is how the communication for the XDot is happening. For the Raspberry Pi, here you can see we have a BMP sensor which basically measures four kinds of values: pressure, temperature, humidity, and the altitude. And here we can also see we have a coolant, so because the Raspberry Pi keeps running for hours and hours and hours. So the Raspberry Pi also has a Wi-Fi connected to it, so it can communicate directly to the AWS. So this is just the hardware implementation of our project.
So as we had seen before, high level, there's the architecture. So here we would now go down deep into each aspect of this architecture and see how the working of it is. So correspondingly, the hardware provider, how you would see, and then the actual API is exposed, and what's the code behind it, and what's the database, how the database schema is, and how the customer would actually see it, and how the device is actually uploading the data. So now the next aspect would be the actual utilization of how a hardware provider would see this. So correspondingly, there's like the home where we would provide all the details about all the platform and how we would utilize it and various aspects of utilization. And the next aspect is, let's say, how a hardware provider would register his own device to be part of our platform. So here the details would be like the device name, let's say my new device, and then the device type would be like, for example, Raspberry Pi for here. And these are the sensors which are connected to the actual device which the hardware provider is trying to register, and this is the actual location details of the device. For now, let's say this is 302 Herald Street in Los Angeles and state as like California. So this is all about the device and its sensors, and now we are trying to register this corresponding device. So now let's see the actual registration when we press the actual registration device. So yeah, so here as we see, we got a couple of things downloaded and the device is registered successfully. So one of the item is the actual binary file which would be deployed in the Raspberry Pi, and one more is the actual device config. So here in the device config, as you can see, there is a device ID generated. So there is a unique string which would identify any device across the world with any sensor uniquely from each other. And how is it, where is it being generated, that's what we're gonna see now. So let's see now. This is the database. So this is running in AWS RDS. So one of the data is the device DB. So see, this is the current live running device data of all the devices and the device name and things like this, the device ID, and then device type, like our Pi is Raspberry Pi, X dot, and it could be added with any other thing. And there are things like temperature sensor, false means it's not present, true, T means it's present, humidity sensor, pressure sensor, and correspondingly, as you can see here, there is something called lat and lon. These are the latitude and longitude corresponding to the GPS coordinates of the location of the device, which was entered in a general manner of street, city, and state. So this conversion actually happens in the back end. So as we saw in the architecture, there's EBS. In the EBS, one of the element is the actual server code, which is always running passively open for all the requests from any client. So here EBS is written in terms of like Express, and it's connecting to our MySQL database with all the aspects like RDS host name, username, password, the port, and the database name. So here after the connection, so the next aspect would be the actual conversion, right? So when device is being registered, like performing registration, we need to convert that physical address to latitude and longitude in terms of GPS coordinates, for which we have exposed an API called /location. So here we are using Google API, Google Maps API, where we would convert that aspects of general street, city, and state to actual location. So here we would get the latitude and longitude. As you can see, this is being returned back to the client. This client could be anything. For now, it's a Angular front end running in a browser. So once that is returned, so the client would perform the next aspect, that is the actual registration of the device with the corresponding values like the device name, device type, the sensors associated with it, and the latitude and longitude, which we saw in the previous API, was the output which the client would have got. And accordingly, all these aspects are unified in the sensor string and things like that. And then the SQL command is generated, in which we insert these all details into the device DB, which we just saw in the MySQL prompt. And now the next aspect is how the customer would utilize this, right? So customer would want a device with some requirements or some capabilities at some location. So ideally there needs to be an API exposed, where once this all request comes in, we would see in our device DB, which we just saw, and find the actual device which suits the needs and provide him with the corresponding device ID. And once this is provided, all the throttling, API security, API keys have to be generated and provided accordingly back. And so apart from that, we need to be able to do all the data upload, right? So once the device is set, the binary which got downloaded gets used with all the device ID. The device is uploading its own data. While it's uploading, the only identification parameter for us to identify in our backend is the device ID. So as you can see, device ID is one of the parameter. The other parameters are like timestamp, the data type, and the data itself. So once this is all there, now we are ready to actually insert this into one of the database. So here we have created something called device data, where we are inserting all these into separate database, but the relation is the foreign key aspect of device ID across the database. So which would be this, and the next aspect would be utilizing of this data, which would be utilized by the customer. So customer would ask for this data download on the basis of what he would have registered or matched the device with. So here accordingly device ID and the data type which he is requesting for. And once the request comes, an SQL query is accordingly executed with all the requirements. And once the response comes, so here the aspect of the requirements and the actual what we store is going back in terms of currently the last 10 results of what we've got as from the output of a device. It can be changed, like it could be as an API where he could ask for last 10 or last 100 or a range of it, or it could be anything like stream data. It depends. Any API could be exposed. It's as generic as a platform. And then corresponding the JSON data with all the values will be returned.
We get all the configuration file, how a hardware provider does the configuration on its side. So here we know we have a readme.txt which will help us to set up our configuration on our hardware device. So the readme.txt has all the steps listed down what I need to follow to configure my device. So the first step for that would be to run the Raspberry Pi code which is given to me. So that I'll be running. So once I start this program, it will continuously start sending the data based upon the demand which has been asked by the customer at the other end. So as you can see, I'm continuously sending the data. It's continuously sending very varied range of temperature. So once the temperature, so since this we are running on the Raspberry Pi has a Wi-Fi built in it, so it's directly sending the data to AWS. So let's see how Akhil at the other end is able to visualize the data.
This is the another aspect of actual data. That is, this is the device data database where we are getting all the data from various devices. One of them is, as you can see, this is the device data which we registered in the previous explanation, and the timestamp and the data type and the data accordingly. So this is the various data. This data can be consumed in many ways. As you could see that it could be Android app, it could be any API stream, or any API consumption. One of them would be like one client consuming it. So it's an Angular front end where customer would see these data values. So this is a dynamic pull model where every time instance, some instance, it can pull the data from the cloud, and if there's any new data, it would show up accordingly.
So let's see the connection of xdot now. So xdot basically will be having a similar binary file which it will be communicating, but since xdot in its sense doesn't have any Wi-Fi connected to it, so it's communicating over LoRa to the conduit, and the conduit has a Wi-Fi which it would be communicating to the AWS. So we have installed a Node-RED application on our xdot, and you can see the flow of the working. So now you can see the LoRa is connected. We are getting a transmitted bit of data. We are passing the data to a format which will be consumable at the API which we have at the server. So we are creating a query and ultimately sending the request. And as we can see, once the data correctly reaches the AWS, we are getting a success message from the server. So this is similarly we'll visualize the data how we visualize for Raspberry Pi at the server side. So this was an end-to-end working of both Raspberry Pi and xdot.
So this is a research data of a cloud computing market size, and as you can see, the hardware contribution is increasing in the near future. So our IoT as a service system would lower down the hardware contribution since we use the existing hardware sensor data for the future deployments, and this would in turn result in a significant decrease in the hardware usage, which would also contribute to a good cause of Go Green future and avoid the e-waste in our near future.
So looking into the future aspect of this project, we can implement APIs which can stream the data directly to the user so that they can actually use the data in their applications. And so along with the graphical representation at our platform, the user will be able to get the streaming data to their application directly. Other than this, so right now we have just used the temperature values for whole demonstration, but we can use different type of sensors such as humidity and other sensors as well. Other than that, we can also enable user to use the direct video streaming, so that can be used for video surveillance. So that can be used by any city's police department for the video surveillance as well. So these are few of the future aspects of the project. So that's all from our side. Thank you so much. We appreciate your time.